Let us test the convergence of the series sum of n plus 1 upon n square into x to the power n. Now, if we have given some unknown quantity like variable x or any other variable, then at that time, we also use the ratio test. We cannot apply other tests over here. So we use the ratio test. So the given series is sum of un equal to n plus 1 into x to the power n whole divided by n square. So here nth term un is equal to n plus 1 x to the power n upon n square. And if you want to find out the n plus 1 terms, we have to just replace n by n plus 1. So n plus 1 to the power x. This n again comes n plus 1, become n plus 1. And the n square will be converted as n plus 1 whole square. And now n plus 1 is nothing but n plus 2 x to the power n plus 1 whole divided by n plus 1 whole square. So un is equal to this and un plus 1 equal to this. Now we know that if we want to apply the comparison, D'Alembert ratio test, we have to take the ratio of un and un plus 1. Consider limit of un upon un plus 1 when n tending to infinity, which is equal to limit of un is what? It is nothing but n plus 1 into x to the power n divided by n square. And un plus 1 is n plus 2 x to the power n plus 1 divided by n plus 1 whole square, which can be written as, we are writing n plus 1. This is the first term. And if you want to write down the second term, it is in the division form. So if we write down multiplication, this denominator term will goes to numerator and this numerator term will goes to denominator. And the division will convert it to multiplication. Now, we will try to simplify it. N plus 1, this is n plus 1 and it is n plus 1 whole square. It becomes n plus 1 whole cube. Similarly, n square multiplied by n plus 2. And here x to the power n upon x to the power n plus 1. Now here, we take n cube outside from the numerator. So if we take n outside, n cube will come out. N cube. And here 1 plus 1 upon n whole to the power 3 whole divided by n we will take outside from here. So n square into n, it become n cube 1 plus 2 upon n. And similarly x to the power n, and this x to the power n plus 1 can be written as x to the power n into x to the power 1. So what are the common terms like that? N cube, x to the power n, x to the power n can cancel. And if we substitute n equal to infinity over here, it is nothing but 1 upon x, right? Because it is 1 to the power 3 is 1, 1 upon 1 is 1, and 1 upon. So 1 upon x is the value of the limit of ratio un upon un plus 1. Now, clearly, here x is not, it is again unknown quantity. But if you want to use the ratio test, if the value of 1 upon x has where its ratio test, the given series is convergent if 1 upon x is greater than 1, which means x is less than 1. And the given series is divergent if 1 upon x is less than 1, which implies x is greater than 1. And the test fails at x equal to 1. Now, we have to check that what is the situation if the value of x is 1. It is very simple. If x is less than 1, series is convergent. If x is greater than 1, series will divergent. But what will happen if the value of x equal to 1? So now our aim is to check the given series is convergent or divergent at x equal to 1. Now we have to check the convergence of the given series at x equal to 1. Putting x equal to 1 in sum of un, it will become sum of n plus 1 to the power into x to the power n upon n square. So if you put n equal to 1, this x to the power n will become 1. So we have n plus 1 upon n square. Now, we have to check that this series sum of un, which is equal to n plus 1 upon n square, is convergent or divergent. So clearly, if you see this series, the nth term contains the algebraic numerator as well as denominator. So now we can use the comparison test. We have to check that the above series is convergent or not. The auxiliary series of this series V of Vn of 1 is given by sum of Vn is equal to what is the highest degree term of n in the numerator. It is n divided by n square. So the answer is 1 upon n. Now, if we compare this series with the P series 1 upon n to the power P, here the value of P is nothing but 1 upon n to the power 1. So the value of P is equal to 1. Now, consider limit of un upon Vn, which gives us n plus un is nothing but n plus 1 upon n square, and Vn is equal to 1 upon n. And if we simplify n plus 1 upon n square into 1 by n will become n by 1. 1 and n will cancel. We have again n plus 1 upon n. If we take n outside from this part, then this n, and n square will cancel. And if we put n equal to infinity, it will become 1 upon infinity is 0. So the answer is 1. Clearly, which is finite non-zero numbers. Now, so at x equal to 1, the given series is converted as a auxiliary series. And if you want to find out the Vn, it is sum of 1 upon n, which is nothing but P series. And if you find out its limit, ratio of the ratio of un upon Vn, which is equal to 1. Now, according to the comparison test, hence by comparison test, both the series un and Vn are converge or diverge together. But by P series test, auxiliary series sum of Vn is divergent. Why? Because the value of P equal to 1 over here. So the series sum of un is also divergent series. Hence, by ratio test and comparison test, the given series is convergent for x is less than 1 and divergent for x is greater than or equal to 1. Thank you.